Functions are a big concept in Algebra 1, and a good chunk of the course focuses on three major function families. However, before we look at math, let's think about something you may have seen in your everyday life: a vending machine. When you press a button, a specific item comes out. For example, if we press button 1, the bag of chips in spot 1 comes out. Button 2 causes the drink to come out of spot 2, and so on. To use math terms, we could say the input is the button pressed, and the output is the item that comes out. What does this have to do with functions? Here's our Algebra 1 definition. A function is a rule that assigns each input exactly one output. This means that for every value you put into the function, the input, there is one and only one corresponding value that comes out, the output. To explain, let's look at the vending machine again. The machine would not be a function if we pressed button 1 the first time and got the bag of chips, but when pressing button 1 a second time, a drink came out. That would be two different outputs for one input, and we'd be frustrated that we wasted our money on something we didn't want. Instead, the machine needs one specific item from a specific location to come out whenever a certain input is pressed. This is a functional machine. Now, functions in Algebra 1 can look like this. We call this function notation. The letter F represents the name of the function because many times in math we work with more than one function at a time, and we need to label them. The letter X represents the input. So we input numbers for X, and the answer we get is called the output. Watch as we animate a few inputs. This is an example of a function because each input number has exactly one output number to go with it. If we graph the inputs and outputs as x, y coordinates, the result looks like a bunch of points forming a line. This brings us back to the three function families of Algebra 1. The example we just saw is called a linear function because the inputs and outputs always form a line. The other two families are called exponential and quadratic functions. These types always look similar to these graphs when inputting and outputting numbers. They have special patterns with their outputs that we'll explore later in the course. Let's conclude the video by looking at how we know if something is a function. Again, for every input, x, there can only be one output, y. So, one way we can tell is by looking at the inputs and outputs together to make sure there isn't more than one output coming from an input. Check out these four tables. Pause the video and see if you can guess which ones are not functions. If you said tables 2 and 3, you're correct. Both of these tables have more than one x value that is the same. It's the same as pressing the number 1 button twice on the vending machine and getting items from different locations. Also, you may have considered table 4 as well because of the repeating numbers in the y column. However, since the repeating numbers are not in the x column, it is okay to repeat. This is similar to a vending machine that has multiple buttons that get the same item. As long as those buttons are getting the right item from the right location, it's okay that the item is the same in those locations. Finally, we can tell by the shape of a graph whether something is a function. Here are 4 examples. Again, for every input, or x value, there can only be one output, or y value. Therefore, to test it out, we can use what's called the vertical line test. We can draw a vertical up and down line and drag it across the graph. This line represents numbers on the x-axis. Therefore, if our line crosses the graph in more than one place, that means there is more than one output for an x value, or input. Watch the animation as it reveals which graphs are not functions.